Hello class! Throughout this video, we will learn about force, motion, and energy. We will go over the definition of mechanical, thermal, sound, light, and electrical energy. We will also give you an example of each. We will learn how they are related and how they play a specific role in our everyday lives.
First off, let's talk about mechanical energy. It is the energy associated with the motion and location of an object. It is the sum of kinetic and potential energy. For example, mechanical energy is used to give a bowling ball the ability to knock out the pins. Mechanical energy is then transferred to the pins when they are hit. Next up is thermal energy. It is energy of moving particles that speed up and then produce heat within the object. An example would be boiling a kettle over a hot plate or stovetop. The heat given off to the kettle from the hot plate causes the water molecules to vibrate at an increased speed and then produce heat of their own. Sound energy is the energy caused by an object's vibration. If you were to play the guitar, you would be using your fingers and arm to pull the strings. This causes the strings to vibrate within the body of the guitar and produce sound energy. The sound energy waves travel in all directions. Now we will talk about light energy. This is the energy presented in the movement of waves of light. The sun outside is giving out light energy at this very moment. Light energy is also known as solar energy. In fact, plants use light energy through the process of photosynthesis. Lastly, let's talk about electrical energy. It is the organized movement of electrons. Lightning during a thunderstorm is a perfect example of this form of energy. With lightning, it is visible to the human eye. It is the electric charge hopping from the clouds to the ground. Another example would be plugging an electronic into an outlet.
Now that we know the definitions of some types of energy, we will look more into electrical energy and how it works in two different types of circuits, how these have to be closed, and some basic terminology that will help you be successful in this unit. Also, the three different types of energy that can be produced from a closed circuit. So, in order to describe a circuit, there are some terms we should know first. We're going to go over voltage, current, and wattage. Voltage is the energy given to each unit of charge that flows in a circuit. Current is the amount of electrical charge flowing past a point in a circuit each second, and wattage is the amount of electrical energy a circuit uses each second. Now that we learned the basic terminology that makes up a circuit, let's discuss what a circuit is. An easy definition is a circuit is simply a closed path that allows electricity to flow from one point to another. A flashlight is an example of a basic circuit. There are two types of circuits, parallel and series circuit. Circuits can be wired in two ways. In a series where current flows to each bulb, both bulbs are dimly lit. Then there is a parallel circuit where the current divides and flows directly to both bulbs at the same time. Here the bulbs appear brighter. While energy flows through the two types of circuits, the connections are just fundamentally different. A complete circuit is the only way current can flow, when there are no gaps. Electrons flow from one negative terminal on the power source through the connecting wires in components such as bulbs in our example, and back to the positive terminals, completing the circuit. Negative to positive. If there is an opening stopping the flow of electrons, the circuit is no longer complete and there is no current to flow through.
The wires in a circuit carry the electrical current to various parts of an electrical system, and it leads to the production of light. A battery or generator produces voltage, which is the force that drives current through the circuit. Remember that a complete circuit is where the current flows and it results in the flashbulb giving out light. When there is a complete circuit, a small bit of energy is released as heat when electricity flows through the conductor. When electrons move through the resistor, they use a lot of energy to overcome the resistance. This energy is then moved to the surroundings in the form of heat. There is a resistor in light bulbs called tungsten wire that makes it hot. When current passes through a buzzer, electrical energy changes into sound energy. An example of this is when you use your phones to watch videos and they make sounds. Energy is produced by vibrations. We have to remember that energy is not created. It simply changes from light, heat, or sound energy.
Another important type of energy is light energy. Light energy comes from things like the sun, light bulbs, and even lasers. Light comes in rays that can either be reflected or refracted. In the next few slides, we'll talk more about what all these words mean and how they all relate to light. This diagram shows what reflection and refraction are. The incident ray is the ray of light that comes straight from the source, like the sun. The reflected ray is what happens when a ray of light hits a surface and bounces off of it. The refracted ray is what happens when light hits a surface but doesn't bounce off of it. Instead, the light bends and travels through that. These two pictures show examples of light being reflected, light hitting a surface and bouncing off of it, staying in a straight line. On the left, the sun shines through the window and reflects off of the mirror the woman is holding, which is why you see only a small part of her face being lit up. On the right, the light from the bulbs is reflecting off of the glass tiles. These are examples of light refraction caused by water and by glass. The way the light appears through water versus through air causes the straw to look different through each, even though it's the same straw. On the right, the ray of light is being bent because it must travel through the glass. This is why it appears differently after traveling through the glass. Mechanical, thermal, sound, light, and electrical energy all use different ways and materials of creating energy. You learned how electricity in closed circuits results in light, heat, and sound energy. You also learned about light reflection and refraction. Now it's up to you to find energy in your everyday lives.